Year 11, today we're looking at how to find the area of a region between two curves. So up to now we have looked at the area between a graph and the x-axis. Right, so something like this, for example. Or if you have a cubic, the area between the graph, like above the graph and below the graph. But it's always been the area between one particular function and the x-axis, whereas now we're looking at two functions. So the method is fairly similar for all your questions. You're obviously going to sketch the graph, always include a diagram, find the point of intersection, and you only need the x values because that will form your lower bound and your upper bound. You're going to shade the regions between the graphs. Have a highlighter with you, it's easy to shade. And then you're going to set up the equation, which is the integral of the top function minus the bottom function. Top function minus the bottom function. So if we look at this example over here, we've got a cubic, and then we've got an upside down quadratic in red. And you can look at the two areas that are enclosed by the two graph, area 1 and area 2. So to find the area of the first section, A1, it will be the lower bound A, upper bound B, and then it will be the top function, blue, minus the bottom function, which is in red. And if you look at area 2, it's now reversed. So it will be the top function, which is red, minus the blue function at the bottom. So that's how you would set up your function that you're going to integrate. So looking at word example 1, tick free. So it says find the area bound by y is equal to x and y is equal to x squared. So you're going to start by sketching it first, so tick free. So you're going to draw an x and y axis. Remember always to label it. And then y is equal to x. Do you remember what that looks like? Y is equal to x is the line, a straight line that passes through the origin, and it makes an angle of 45 with the x-axis. So remember, this doesn't have to be according to scale, just that line passing through the x-axis. And then the parabola y is equal to x squared. Do you remember what that is? A parabola passing through the origin, and it sits neatly on the origin like that. Again, you don't have to do it according to scale, but always label it. So that's really important. And then it says find the area enclosed. So you can see it's this little area over there. Okay, so setting up your area function then will be a equals the integral from 0 to 0 is my first intercept there. You can see it's 0. It sits on the x-axis there and the y-axis, and then to this point over there. So how do I find that point of intersection? So because it's tick free, you'll have to do it algebraically. So this is how you find the point of intersection. You equate the two functions. So that's important to remember. Is where one function is equal to the other function. So x is equal to x squared. Remember here, please don't go and divide by x both sides, because then you actually divide one of your solutions away. We never do that. Take the x to the one side, take on a common factor x, use the null factor law, so x is equal to 0 and x is equal to 1, which makes perfect sense, doesn't it? Because x is equal to 0 is my lower bound there, and x is equal to 1 is my upper bound there. And again, remember, you don't need to find the corresponding y values. We're just interested in the x values of the point of intersection. And then you'll set it up on the right-hand side. Lower bound is 0, upper bound is 1. Write it in. My top function, so slow down here. The function at the top is my linear function, which is x, minus the function at the bottom is my quadratic. So it's x take x squared. You can't simplify that, so you go straight into integrating it, subbing in the 1 and 0, remembering your brackets, and you get 1 over 6 and then unit squared. All right, so that's an example of a tick free. Tick active, so it's a lot easier if it's on tick active. There are your two functions, so you straight away go to graph mode and type it in. So stop and pause the video so that you can do that. Once you can see that clearly on your graphics calculator and play around with view window, you've got to sketch it. So that's important. Clearly label your two graphs. You can see I've labeled my quadratic in red, my cubic in blue, and I've used my highlighters and I've colored in the enclosed areas between those two graphs. And then you're going to split it up into area 1 and area 2. So for area 1, before you do that, you now need your points of intersection, or the X values. So on your calculator, you can just go GSolve, points of intersection, and that must be clearly labeled on your diagram as well. So take a moment to do that. And then working from left to right, you'll have your lower bound and upper bound. So the blue area, lower bound negative 1.158, upper bound 0, top function minus my bottom function. So it's my cubic, as you can see in your sketch, minus my quadratic. And you can just work it on your calculator. And for area 2, then my top function is my quadratic, my bottom function is my cubic. Subtract that and look at your bounds. The lower bound is 0, upper bound is 2.158. And then you'll add the two areas to get your total area. So just have a good look at this one. Slow down on your calculator. Make sure you're happy with the calculator work. And then in your textbook, we've got those questions there for you. Really good questions, very similar to what you'll get in an exam. And then a really good question that Joel Speranza talks about in this video. So if you go to the timestamp 241, he talks about this question, and then the answer is at 7:50. Really good one, just to listen and go through that. So yeah, please check in with me if you need any further help.